Welcome to this course on mooring system maintenance. This course is designed to enable you to explain the importance of safe mooring systems, identify the different equipment used as part of mooring systems, describe necessary maintenance work to ensure safe working of mooring systems, and explain the importance of maintenance schedules and procedures. At the end of this course, there is an assessment. These questions are assessed and have a 70% pass mark, so please pay close attention and think carefully about your answers. Accidents during mooring operations are one of the most common types of incidents occurring on ships and can have dire consequences, risking even the life of seafarers involved. Japan's Accident Investigation Board reported 95 incidents within a 4-year time window, out of which 31 were related to mooring and anchoring. These accidents resulted in 11 fatalities, 13 severely and 7 slightly injured persons. A major UK-based marine insurer has reported that over the last 20 years, 58% of crew injuries occurred during mooring operations. This demonstrates the utmost importance of mooring safety. While many accidents happen due to the lines, about 5% are related to equipment failure. Besides accidents during operations, mooring has an essential role in securing the ship alongside in any wave and wind condition. To ensure that the mooring system remains reliable and to minimize the risk of accidents, regular maintenance of all involved parts is essential. The Safe Working Load, SWL, means the maximum safe load that a fixed piece of equipment can handle without risk of breaking. The Working Load Limit, WLL, is the maximum safe load for a mooring line. The maximum load a mooring system can safely handle is only as high as its lowest piece, and therefore depends on the SWL and WLL of its pieces. The WLL is expressed as a percentage of the ship design minimum breaking load, MBL, the minimum load at which a new and dry mooring line could break. It is 55% for steel ropes and 50% for any other material. The MBL varies per size and type of rope. It needs to be checked carefully to ensure it meets the requirements of the ship. When a mooring line is exposed to loads exceeding its WLL, it does not break immediately. However, it may get damaged. The ship's mooring safety management plan and line management plan should include procedures to manage this risk, such as service condition monitoring, sample testing, wear zone assessment, detailed inspections, and retirement of rope when needed. Mooring system maintenance also needs to ensure that fixed parts, such as winches, operate at their designed SWL. Mooring systems can be complex and include various fixed equipment on board of the vessel. Select each link to learn more. Mooring stations are equipped with either single or split drum mooring winches. These can be powered by hydraulics, electricity or steam motors and are equipped with a drum brake that can be applied automatically or manually. The capacity of the mooring winches is determined during the vessel design. Effects on the ship, based on its size, its maximum wind area and underwater area affected by streams, are calculated and compared with the number of lines that are to be deployed and the MBL of these lines. The winch heaving load is set lower than the MBL of the lines to avoid the winch motor applying excessive load. The motor and other parts of the winch experience regular wear and require maintenance accordingly. The brake secures the winch drum and through it the mooring line itself. It is important that the force of the brake is lower than the line's maximum load. Instead of braking during excessive load, the brake will render and allow the line to release the excessive load. As a result of this rendering, the line slips, leading to wear on the brake band. Therefore, the brake band needs to be inspected regularly and replaced in good time. The windlass drums on the winches are not designed to hold mooring lines under load. If lines are placed on drums instead of bits, then these drums will experience wear and even shaft bending damage. Even when using them only to move lines, regular inspection is needed. Bits are the standard posts on which mooring lines are secured and directly connected to the ship's structure. They are built as a pair to enable easy line placement and should be clearly labelled with their SWL. Bits require the least maintenance during regular use, but their structural integrity is essential for mooring. Chocks and fair leads guide the mooring lines and are reinforced to ensure that the structure can handle the load. Their SWL exceeds the MBL of the mooring lines. Chocks are relatively easy to maintain, mostly requiring only regular coating as the paint is abraded. Fair leads include moving parts and need a more thorough maintenance to ensure safe working. Ropes become lines when used for a specific task, such as mooring. Therefore, the material, as well as the equipment in an unused state, are referred to as rope. However, when used during mooring, it is a mooring line. Mooring lines are made either of natural or synthetic fibers. Most commonly, they are made from conventional synthetic fibers, such as polyester, nylon, polypropylene, or more specialized fibers like aramid. Alternatively, steel wires can be used for mooring. Such wires are not elastic and are therefore combined with length of synthetic tail line to absorb small ship movements and reduce load shock. It needs to be ensured that the tail line MBL is not exceeded to avoid snapback. The same type and size of line should be used for the same service. It is possible to combine different types for different services, for example, having spring lines made of wire and bow and stern lines made of synthetic fiber. The International Maritime Organization, IMO, published guidelines on the design of mooring arrangements and the selection of appropriate mooring equipment and fittings for safe mooring, which should be considered when selecting mooring equipment. All ropes require proactive care and proper storage to maintain a long and safe service life. Ensuring that lines are stored correctly is an important part of preventive maintenance. Storage of lines should be done in a protected area to minimize the influence of weather, UV light, extreme temperatures, water, chemicals, and cargo. Twist and turns should be removed from lines before storing. Using covers, mats, or protective sleeves can help to further reduce the need for line replacement by protecting against friction. All parts of mooring system should be routinely inspected in accordance with the maintenance plan and procedures, such as the plant maintenance PM system. It is essential to always follow the specific processes on board and to ensure that these are in line with the manufacturer's guidance. The IMO guidelines for inspection and maintenance of mooring equipment, including lines, provide further guidance. Practical experience with specific lines should also be considered during inspections and when reviewing the respective processes. Inspections should include records of the number, type and location of mooring lines, tails and other attachments in either the mooring arrangements plan, the records of inspection and maintenance, or other appropriate document in accordance with the company's procedures. The number of fully functional lines available should always be in line with the minimum standards defined in the IMO revised guidance on shipboard towing and mooring equipment. Records of inspections and maintenance of fixed equipment and fittings, as well as their original design concept, should also be available on board. Different industry bodies have established standards for specific types of vessels. The most important ones are the Oil Companies International Marine Forum's OCIMF Mooring Equipment Guidelines. These guidelines include recommended minimum requirements that are addressed to ship operators and the crew, as well as to ship or terminal designers, and even mooring line manufacturers. Oil tankers that are inspected by OCIMF may be required to fully adapt these guidelines. However, they are a best practice for all types of vessels. The recommendations include a mooring system management plan and a line management plan. Select each link to learn more. The Mooring System Management Plan aims to harmonize methods for maintaining information about the mooring system, such as original design data and maintenance records. The goal is to make it easier for the crew to access all relevant information about the mooring system for maintenance. The line management plan is specific for each type of mooring line used on board. It contains information about that line and its attachments, such as tails, including criteria for installation, maintenance, and retirement. Ships that cannot yet comply with the recommendations should record changes, timelines, and interim measures to work towards a full adoption of the guidelines. The exact requirements for inspection depend on the type of mooring line. However, generally all lines should be inspected visually for excessive wear, damage, external abrasion, fiber degradation, external cut or kink, heat damage such as fusion, and fraying or slackening of spliced eyes. The manufacturer can provide clear images to identify the state of the line. If jacketed mooring lines are used, the actual load-bearing fiber inside the line cannot be inspected visually. The condition of the external jacket is not representative. Depending on the findings, individual lines may need to be rotated to other positions to avoid exposing them to the same stress. Lines that have excessive damage need to be replaced before failing, in accordance with the manufacturer criteria. If defects are detected during mooring operations, these should be immediately reported to the master and other involved parties, including the mooring personnel ashore. Besides the mooring lines, the fixed equipment and fittings should also be inspected regularly and maintained according to findings. Inspection and maintenance may be done by different disciplines on board, such as deck ratings, deck officers, or specific engineers such as the electrician or electrotechnical officer. When performing visual checks, it must be ensured that equipment is free from corrosion. Moving parts should be able to move freely and should be well lubricated. Bearings of fair leads should be greased regularly, and it should be possible to operate them manually. Any surface that has contact with mooring lines should be smooth without rust or sharp edges, and cleaned regularly to enhance the life of the mooring lines. Control switches should move freely. Indications should be well labelled, and all lights and alarms must be in good working order. The required maintenance work is outlined in the PM system, according to the maintenance schedule. Remember, no work should be carried out without the strict permission of the master. Common maintenance includes painting, checking hydraulic oil levels, inspecting electrical winches, checking moving parts, evaluating structural integrity, identifying corrosion, checking brake linings, inspecting securing arrangements, and brake testing winches. Select each link to learn more. Painting parts where the coating abraded through friction to protect the steel from corrosion. When painting, any marked information, such as the SWL or winch control instructions, needs to be preserved, for example by placing it on top of the new coat of paint. Checking the oil levels in the main system of hydraulic winches to ensure that there are no leaks present around the tanks or pipework, especially during a test run. If any of the maintenance involves topping up or changing of oil, spill kits should be made available. Ensuring connections of electrical winches are tight and sealed. Ensuring the necessary moving parts, such as gears and clutches, move freely and are not corroding. Most will have various greasing points. Ensuring that all machinery is structurally sound. There should be no cracks or warps, especially in the welded parts, and all bolts and joints should be tight and secure. Checking that all machinery is free from major corrosion, which may weaken the overall capacity. The paintwork should be in good condition. Ensuring that brake linings have sufficient wear left and the brake and clutch tightening and release methods are free and easy to use. The brake drum should be free from grease, paint or corrosion. Ensuring that securing arrangements should be in a good condition and free from corrosion. Winches should be inspected regularly and maintained as per manufacturer guidelines. Winch brake tests should be performed in regular intervals and after every maintenance to ensure the brake renders before the MBL of the line is reached, while still holding the ship in place. Let's try an activity to test your understanding. Which of the following actions can ensure that mooring lines maintain a long and safe service life? When you are happy with your choices, select the Submit button. Sorry, that's incorrect. The correct answers are being shown for you now. Well done. You have almost completed this course. You should now be able to Explain the importance of safe mooring systems. Identify the different equipment used as part of mooring systems. Describe necessary maintenance work to ensure safe working of mooring systems and